This is Sharma solution, class 12, chapter 6, determinants. Exercise is 6.2. So this is with the trigonometric relationship and identities. We are going to use expressions we are going to use. So what we see here is in the third column, we have cos alpha plus eta. Now, sin alpha and cos alpha is already there in the first and row column. So if we multiply the first column with sin eta, let us call it as eta, this symbol, and if we multiply this column 2 by cos eta and then try to subtract them, then we will eventually find the third column, right? So this is what we are doing. I'm trying to show you. Okay, column 1, we are multiplying column 1 with sin eta. So this will be sin alpha, sin eta, sin beta, sin eta, sin gamma, sin eta. So now we will multiply the column 2 by cos eta. So what it will be? It is cos alpha, cos eta, cos beta, cos eta, cos gamma, cos eta, right? Now we already have cos alpha plus eta, beta plus eta, and gamma plus eta. Why we multiplied with sin eta and cos eta? Because we already see that there is an eta on the third column, right? Okay, so now what we do, we change the column 2 with column 2 minus column 1. You can also do column, because we know the formula, that is why we are doing cos this column 2 minus column 1. So I am doing this first one, cos alpha cos eta minus sin alpha sin eta. What do you get? You get cos alpha plus eta. There is cos A cos B minus sin A sin B is cos A plus B. And we are doing cos 2 minus the C2 minus C1. So the second column will become cos alpha plus eta, which I just showed, and in the same way the second one will become cos beta plus eta, third one will become cos gamma plus eta. And now you see the third column and the second column, they are exactly similar, they are same, right? And we know when we have similar, same identical column, two column or identical row, then it will be 0. I'm not writing the first column because you know what is the first column. Now this one, how to do this? There are multiple ways to do it, and we have already done a question like this. So I'll just give you a hint how to do this. And you can use row, you can use column, it's up to you, right? There is no strict rule that what you have to follow, what you have not to follow. So we have certain columns here, 3 columns. So I am adding these through 3 columns, column 1 plus column 2 plus column 3. What do you get? You get A plus B plus C. Then we have A minus B, B minus C, C minus A, and we are changing it to column 1, so it will become 0. Now B plus C, C plus A plus B. What do you get? Twice of A plus B plus C, because it is 2A, 2B, 2C. So twice of A plus B plus C. Now the second column, third column, second column will be B, B minus C, C minus A, C plus A, and A plus B. Okay, from the first column, A plus B plus C can be taken common. So I am taking A plus B plus C common. And what do we have inside? 1, 0, 2, B, C, B minus C, C minus A, C plus A plus B. So in order to get 2 zeros, you can use the twice of this. That is, you take the twice of the first row and you can subtract it with the third row. But eventually you have to do the multiplication, that is, you have to open this determinant, right? There are multiple ways, as I said. So you can try other way, you can try the way I am suggesting, or you can try the way the solution being printed given to you on the left hand side, which you see here. So there are multiple ways which can be used to deal with this solution. So what we do? So we are doing something like this. Row 3 we are changing, row 3 minus twice of row 1, and this is just to make the one of the value 0 in the first column. Okay, 0, 1. Now twice of 1 minus 2 is 0. C plus A minus 2B it will be. So B minus C, it is C plus A minus 2B. It's not B, it's straight 2B. Okay, just change it. C plus A, C minus A, and this A plus B minus 2B. It will be minus 2C here. Minus 2C. Right? So now what we get here is that we have two zeros here. So we will open using the first column. When we open with the first column, first will be 0, second will be minus 1 into something. What is minus 1 into something? You have BC, C plus A minus 2B and A plus B minus 2C. The first one and last one will be eventually 0. So don't worry about that. We just need to worry about this negative is outside, right? B plus C, C plus A minus 2B, A plus B minus 2C. Now when you do this computation, outside it was A plus B plus C. So I'm not doing the calculation. I'm just saying B into A plus B minus 2C you have to multiply, and C into C plus A minus 2B you have to multiply and subtract them. So finally you will get A square plus B square plus C square minus AB minus BC minus C. A plus B plus C was already there, which we took already in the beginning. And when you multiply this, you will get A cube plus B cube plus C cube minus 3ABC. So there are multiple ways. Let me reiterate. One way I told you, one way is given to you. So this is also something like this. So either you find some way to do it, means some row or column applying the properties. If you are able to do it, it's good. Otherwise, if you are stuck, you are not able to understand or devise what properties we have to use. So best one is to open it. I'm just giving you an idea. If you add these three columns, what do you get? You get C plus 2A. So you're not getting any benefit. The benefit is only when you get 1 or 0. Then it is worth doing. So what you have to do, I'm going to show you here only, because it's simple multiplication determinant. B plus C here, minus A minus B here, because minus 1 to the power I plus J is first row second column, so it will be I minus I to the power 3. So it will be negative. B plus C, when we avoid those rows and column with B plus C. Okay. Now what we do, we will do the cross multiplication here. B minus C into C minus B into C minus A. Then similarly A minus B, and then we do the third one, that is A into whatever is inside. So I hope you'll be able to do it. We have done it already. So this is simple calculation. Rearrange, cancel whatever is there, add, and finally this will come. Now this question is very important because it has already come in 2001, 2004, 2006, 2007. There is one property which you have to apply here. It will make it so easier. Two matrices you can make out of this one matrix, or you can find a determinant by making or dividing this matrix into two different matrices. How do we do this? See, this is first participant of the plus I am taking. This one, and this one. This will be one matrix. That is, this will be A, B, C. You have here B, C, A. Then you have C, A, B. C, A, B. Now add it plus. Now the next one will be the second participant which you see in with the addition. You have B, C, A, C, A, B. And this is the property. You can divide the matrix into two if you have a plus sign. A, B, C. Now how to do this? Because they don't seem to be similar, but if you rearrange the rows or the columns, you are going to get the equal matrix, right? That is, you can either change the columns or you can exchange the columns or exchange the rows. So you have whatever is in row, you are getting it in row 3. What is in row 2, you are getting it in row 1. And what is in row 3, you are getting in row 2. Okay. So if you replace the row twice, that is first Either make the first one as second one or second one as first one. It's up to you. Either change the columns or either change the row. I am changing the row. You can also get the same answer by changing the or exchanging the columns as well, because in the solution I have already given you column changing, but I am changing the rows. So now first R1 and R2 I am exchanging. What I am trying to do here is, let me just write it, because row 1 and row 2 has to be exchanged. So this is the column version, and I am actually explaining you the row version the same way. So row 1 we are exchanging with row 2. Row 1 we are exchanging with row 2. So what do we get? You get BCA will come above, ABC will go down, and CAB. Okay. Now when you exchange it, it will be negative, because negative sign will come. Now row 2 will be exchanged with row 3. Row 2 and row 3 needs to be exchanged. So what do you get? BCA will remain there in the first place. Now we are exchanging the row 2 and row 3. So CAB will go up, AB and C will come below. What do you see here? First row change, minus sign. Second row change, again minus sign. So minus minus becomes plus. So minus minus becomes plus. Now we have this matrix and this matrix exactly same. These two matrices are exactly same. So it will be simply twice of ABC, BCA, CAB. I am just doing it in other way, because this is twice of BCA, CAB, ABC. But the question is asking about twice of ABC, BCA, CAB. So I would urge you that you don't need to change the first matrix which I did. You need to change the second matrix. Exchange this first and second row and second and third row in the second matrix, then you will get the answer. So this also has come, this is an NCERT question, this also has come various times. So let us make it quite easier, or the level it can be easier to you, because the main thing is maximum ones and maximum zeros you want. So if you see here that this is A plus B plus 2C, 2C, and if you add these, what do you get? A and B. So you get 2A plus 2B plus 2C, right? 2A plus 2B plus 2C. 2A plus B plus C, and this you can do with all of it. So column 1 we are changing to column 1 plus column 2 plus column 3. You are adding 3 columns and adding it here. So column 1, column 2, column 3 you are adding. It will be, see, it will be 2A plus B plus C, and same for others also. So I'm making just to show that these are different columns, I'm just making a lining here. C plus B plus C plus 2A plus B will always be 2A plus B plus C. Similarly, C plus A plus C plus A plus 2B will also be 2A plus B plus C. The rest all remains the same. So the first column has become twice of A plus B plus C. So what do we do here? We will take twice of A plus B plus C common from here. It will be easier for us. So twice of A plus B plus C I am taking common. What do you get inside? 1, 1, 1, 1, 1, A, B, B plus C plus 2A, here B, then you have A, then C plus A plus 2B. Okay. Now you don't have to worry about any other thing, you just make 2 zeros. When we have a whole column or a row as 1, just try to make them as 0. 2 zeros you will get. So what do we do? We have 3 rows here. So row 2 we are changing row 2 minus row 1. Row 3 we are changing row 3 minus row 2. Okay. So see, the only thing is either way you do. You can also do row 1, you can change row 1 minus row 2, and row 2 you can change row 2 minus row 3. It's same. But we don't want the negative sign, that is why we have done this. So what I am doing is 1 minus 1, this is 1 minus 1 is 0. First row remains the same, because we are changing row 2 to row 2 minus row 1. So 1 minus 1 is 0, B plus C plus 2A minus A is B plus C plus A, then B minus B is 0. Then we are doing row 3 minus row 2. We are changing row 3 as row 3 minus row 2. Row 3 minus row 2. Okay. 1 minus 1 is 0. A minus B plus C means A minus B minus C minus 2A will be B minus C minus A. C plus A plus 2B minus B will be C plus A plus B. Right. If you see the third row very closely, 1AB is already there. From here, second row, we can take B plus C plus A common. And from the third row also, you can take B plus C plus A plus B plus C common. So from the second row, I have taken A plus B plus C. And the third row, this minus B minus C minus A, if you take negative outside, it will be A plus C, B plus C. So when you take A plus B plus C out from the third row, A plus B plus C will also come again. So A plus B plus C is coming thrice. First 2 into A plus B plus C. Then you have A plus B plus C from the second row and from the third row, A plus B plus C. So you have A plus B plus C cube. So what is left inside? Because since there are 2 zeros in the first column, we'll open it using the first column. So 1 into, you get 1, 0, minus 1, 1, 1, 0, minus 1. Then you have minus 0 into something. You don't worry about that, plus 0 into something, because it will be 0 always. So it will be 1 into 1 minus 0. So 1 it will come. So it will be twice of A plus B plus C cube. Please remember, A plus B plus C was already there. Then we took the A plus B plus C from the second row. Then we took the A plus B plus C plus from third row. And then that is how it became the third power. Now this one. So you need to see what all you can do to get it easier. So if you see that if you add the 3 rows, you will get A plus B plus C. Or you add the 3 columns. Either you add 3 rows, either you add 3 columns, you will get A plus B plus C. So I am changing the row to row 1 plus row 2 plus row 3. A minus B minus C, I am taking the first one, plus 2A plus 2A plus 2A. So I am doing the row 1. So column you have to do 2A and 2A. So that will not solve a purpose. So that is why we have to do row 1 plus row 2 plus row 3. Similarly, the second one I am doing, all these I am adding now. So what do you get? A plus B plus C again. Again the third one here. So 2A plus 2B plus C minus A minus B is going to give you what? Plus C minus A minus B. 2A minus A is A, 2B minus B is B, and C, so A plus B plus C. Right? So row 1 we are changing as row 1 plus row 2 plus row 3. Okay. So the first row will be A plus B plus C, A plus B plus C, A plus B C. You just saw it, so I am just taking it outside. So just assume that A plus B plus C was already there and we have taken it out. So only 1 will remain inside. You get 1 here, 1 here, 1 here. Then you get 2B, 2C, B minus C minus A. And then you have 2C, then 2B and C minus A minus B. So as we know, when we have 3 ones in any row or column, we try to make it as 2 zeros. You will not get any benefit with anything. You just have to do the column 1, it changes to column 1 minus column 2 changes to column 2 minus column 3. This is what you can do. So column 1 we are changing as column 1 minus column 2, and column 2 we will be changing as column 2 minus column 3. I'll just show you. So column 1 is 0, 1 minus 1 is 0. Now 2B minus B plus C plus A. So B plus C plus A plus B plus C it is. 2C minus 2C is 0. And now you have to do C2 minus C3. 1B minus C minus A and 1, 2B and C minus A. See, you don't have to do anything now because we already got 2 zeros. So you don't have to do C2 minus C3 as I just suggested. Already 2 zeros are there. So first 0, then plus, it will be negative, minus of A plus B plus C. I'll just change it. And plus, it's a change, okay? There's a correction. A plus B plus C will be preceded by negative and this 0 will be preceded by plus. And what will be inside it with A plus B plus C? 1 C into C minus A minus B into 1 and minus 2C. So So what do you get? Minus C minus A minus B. But as I just told you that this minus is already there outside. Okay, A plus B plus C was already there in the beginning. We took it. Then we got A plus B plus C outside here in the middle. Then inside also you got A plus B plus C. And since negative was already there, negative negative becomes positive. This is the first one, then the second one, and the third one from inside, the 2 by 2 determinant. So this minus minus will become plus, A plus B plus C already we have, and then we have 3 ABCs here. A plus B plus C whole cube. This is what is the answer here. Now this is again we'll try to make 2 zeros. If at all any other way it is possible, you can do it. So this is row 1, row 2, row 3. We'll just try to make maximum zeros possible. So row 2 we are changing row 2 minus row 1, and in row 3 we'll change row 3 minus row 1, row 3 minus row 2. Okay, whichever way you want, because we need 2 zeros. That is the whole criteria. So we get 1 minus 1 is 0, C plus A minus B minus C is A minus B, C square plus A square, C square plus A square minus B square minus C square, this C square gets cancelled, you get A square minus B square, A square minus B square here. Okay. Now row 3 change, row 3 minus row 1, because row 2 already we have changed, so we cannot take row 2. So row 3 minus row 1 has to be there. 1 minus 1 is 0, this A plus B minus B minus C will give you A minus C, then A square plus B square minus C square, you get A square minus C square. Okay. Now what we can do, A square minus B square can be written as A minus B plus B, and A square minus C square can be written as A minus C A plus C, right? Because it is A square minus B square is simply A minus B A plus B. A square minus C square is A minus C A plus C. So you take A minus B common from the second row. These two I am taking common. So A minus B will outside. So 1 B plus C, B square plus C square. Here you get 0, A minus B. We already taken common. So 1, only A plus B will remain because A minus B has been taken common. And similarly, A minus C taken common. 1 A plus C will be there, 0 will be there. Now we'll open it using the first column. What do we get? B minus C, A minus B was already there. So the inside should come as C minus A, or A or C will be there. So A minus B minus B minus C already there. A minus C, A minus B, A minus C. I'm so sorry. A minus B, A minus C. Okay. So A, B and C should come. So I'm doing it. Just remove the second 2 zeros. What do you get? A plus C minus A minus B. So C minus B it is. So this is the final answer, A minus B, A minus C, C minus B. But if you see in the question, they are asking A minus B, B minus C, C minus A. So you can just change the sign, and this negative can be taken with some other, say, the factor. So I am making it as C minus B as minus B minus C, minus taking to the A minus C, it will become C minus A. So this is the final solution. Okay, this we are going to take in the next discussion. Thank you so much. Take care of yourself.